Hey guys, Mr. Mackey here, and welcome to Probability Week. Now, what probability is the likelihood of certain events occurring, from very likely to almost impossible. Now, impossible is kind of something that I'm not a big fan of, because whenever someone says something's impossible, I wouldn't call it impossible. It's highly improbable, which means it's very unlikely to happen. Now, before we go into loads of different types of probability and how they'll help us and how we can represent probability, which is what this whole week's about, I'm firstly going to go through a few examples where we can identify the probability of things and determine whether that means it's likely, unlikely, or improbable. Let's see what we can do. So here are 4 different words that we can use to describe the probability of some events happening. Certain means it will happen. 100% I am certain that this thing will happen. Likely means it could happen, but there's still a chance that it might not. Unlikely means that it's most likely not going to happen, but it still could. And improbable means it's very almost certain that it won't happen. Like, no, it probably won't happen. So, let's give 4 examples of something that's certain, something that's likely, something that's unlikely, something that's improbable. So today is Monday, the 18th of May. So something that's certain is that tomorrow will be the 19th. Tomorrow will be May 19th. That is certain. That is going to happen. I am 100% certain that tomorrow will be May 19th, because today is May 18th. That could also be linked to the improbable option. If someone was to come up to me and say, well, tomorrow is going to be April 24th, that's improbable. It's very likely that will not happen. Tomorrow will be April 24th. Because today is May 18th, tomorrow it's not going to be April 24th. So what about something that's likely? Well, if someone came up to me and said, it's going to be sunny tomorrow. Looking out my window right now, it is actually very sunny. And because it's been sunny for most of this week, we can assume that it will most likely be sunny tomorrow. So let me just get a different colour pen. Sunny tomorrow. So what am I saying is unlikely? So someone could come up to me and say, tomorrow it will snow. That is quite unlikely, bearing in mind this is very nearly the summer. It's been sunny almost every day this week, but it could snow tomorrow. It most likely won't, but it could. So that would be fairly unlikely. These are all different types of probability. Now, let's see how we can actually find the probability of an amount. So, I have a coin. Regular 10p coin. Heads this side, tails this side. Now, I predict that when I toss this coin, I will land on heads. What's the probability of this occurring? Now, how I always represent probability is I like to represent it as a fraction, unless I'm told not to. Now what I do is I write on the top the number of events I win, and at the bottom number of events in total. So let me explain what that basically means. When I toss a coin, I could either land on a heads or a tails. That means there's 2 events in total. So that's what the bottom part, the denominator, will be. Now, out of those 2 events, landing on tails and landing on heads, how many of those will result in me winning? Well, if I wanted to land on a heads, that would be my win. And because there's only 1 chance that would happen, it would be 1 out of 2. Which means it's fairly likely that I would land on heads, but there is still a chance that I will land on a tails. So let's toss a coin now. It's tails, which means that there's still a chance it could happen. So we can't say I'm certain I'll land on a heads, because this is 50-50. You still can't tell. What about if I predicted that I would land on a heads or a tails? So if I landed on heads, I win. If I landed on a tails, I'd win. Now that would mean that out of every single event that could possibly happen, each event would result in me winning. So the probability of that would just be 1. Because 2 divided by 2 gets 1. And that is an example of something that is certain. I am certain that I will land on a heads or a tails. If I said that I predict that I will not land on a heads and not land on a tails, that means out of the 2 events, 0 of them will result in me winning. So the probability is 0, which is improbable. It is very improbable that I will win in this circumstance. So you can find the probability of loads of these things. Now let's look at another one. Now, like coins, probability can also work for dice. I have a 6-sided dice here, 1, 2, 3, 4, 5, 6, all numbered. Now, I predict that when I roll this dice, I will land on a 3. What's the probability that I land on a 3? So, how many different events are there? Well, there's 6 different numbers on the dice. 3 is definitely a number on there. So there's 6 events in total. How many of those events will I win? Well, if only one of those numbers is a 3 and that's the number I need to win, it's 1 out of 6. Now that is fairly unlikely. The likelihood that I would roll a 6-sided dice and I will land on a 3 is fairly unlikely. Let's see. I rolled a 5. See how unlikely it is? It's still possible because 3 is definitely on here, so I could definitely get one. But it's very unlikely. What if instead I said I wanted to roll a dice and I predict that I would land on a number that isn't 3? Well, there's 6 events still because there's 6 faces on the dice, and 5 of those numbers is not the number 3. So it would be 5 out of 6. Now this event is very likely because there's 5 different numbers. Any of those would result in me winning. Let's see. I rolled a 6. See how likely it is? But it's still possible to get a 3 from that. What if I said that when I roll this dice, I will win if I roll an odd number, which means 1, 3 or 5? Well, there's 3 numbers that are odd out of the 6. So the probability is 3 out of 6. That can be simplified to a half. This is another good example of a 50-50. It's not more likely to roll an odd number than it is to roll an even number. They're equal probabilities, which means that there's a 50-50 chance that I will win. I rolled a 6, so I didn't. But it's still likely that I would have rolled an odd number if I did. What if I said that I wanted to roll a number that was, let's say, 7? I wanted to roll the number 7. Well, I have a 6-sided dice numbered 1 to 6, and out of those 6 numbers, none of them are 7, so the probability would be 0 over 6, resulting in a 0. This would mean that is improbable that I would roll a 7 on this dice, because it's not on there. The probability is 0. So you can get loads of different probabilities from just a dice and a coin. It's quite cool when you think about it. Here is your challenge for today, guys. I've got a coin, and I'm going to toss this coin twice. What is the probability that both of those times I score 2 tails? See if you can work it out. You know the probability of scoring 1 tail. See if you can find out the probability of scoring 2 tails in both those times. Is this likely? Is it unlikely? Is it certain? Is it improbable? See what you can find. And tomorrow I'm going to show you a brand new method on labelling and laying out probability to help you find outcomes like this from occurring. Good luck with this. I'm looking forward to doing more Probability Week with you guys. Have fun, take care, see you later.